Hello everyone, it's Jay, and today we'll be going through a problem involving forces and free bodies. So, I'll first go through the problem and highlight the important information. So, we're told that box A and box B are in contact on ice, and we have a diagram of that situation. We know that box A has a mass of 20 kilograms and that box B has a mass of 5 kilograms. We also know that a horizontal force of 100 kilograms meters per second squared is exerted on box A. And I've highlighted that in red because it's exerted on box A. And we want to know what is the magnitude of force that box A exerts on box B. So we'll start by filling in the important information on our diagram. We know that box A has a mass of 20.0 kilograms. And we know that box B has a mass of 5.0 kilograms. We also know that there is a horizontal force of 100 kilograms meters per second squared exerted on box A. So let's draw that arrow horizontally from the person. And we know its magnitude, 100 kilograms meters per second squared. We also know that there is a force that box A exerts on box B. And we don't know its magnitude, we will label it force AB. So if box A exerts a force on box B, then box B must push back on box A. You can actually try this yourself. If you take both of your hands and push really hard with one hand, you'll see that the other hand pushes right back on that first hand. So if box A pushes on box B pushes on box A right back. Now, we do have gravity and the normal force, but as you'll recall from Angela's video, those two forces cancel out on a flat surface. And now we can do our Newton's second law analysis for our free bodies. And if you'll recall, Newton's second law is that the sum of forces on a free body are equal to the mass of that free body times its acceleration. So let's start with free body A. So we know we have our horizontal force of 100 kilograms meters per second squared, and our force AB, which acts in the opposite direction, so we use a minus sign. And that is all of our forces on free body A. That is equal to our mass of free body A times its acceleration. Now, let's do free body B. There's only one force acting on free body B, that is force AB. So we put force AB is equal to its mass, 5.0 kilograms, times acceleration. And we know these two accelerations are the same because boxes A and B move together. So now we have two equations and we have two variables, force AB and acceleration. So let's take our equation for B and let's multiply by 4. This gives us that 4 times the force AB is equal to 20 times A. And now we'll see we can plug right in to our equation for box A. So we see that 100 minus force AB is equal to 4 force AB, or that 100 is equal to 5 force AB. And from that, we know that force AB is equal to 20.0 kilograms times meters per second squared. So the magnitude of the force that box A exerts on box B is 20 kilograms times meters per second squared. This is pretty surprising since the original force on box A is 100 kilograms times meters per second squared, but it's important to keep in mind that the force on box B must be less to match the same acceleration because its mass is less. So the final answer is 20 kilograms times meters per second squared. Thank you so much for watching, and I hope this video is helpful in solving future force problems.